Robert, you're on, man. What's up? Who are you? What are you talking
Yeah,
about today?
a little bit of functional programming and how nobody's talking about that and mention D in the same time. Because
So,
D is an awesome functional programming language.
okay, that was my next question was why?
Fair enough.
Yeah,
Yeah,
so what prompted this talk though? I mean, what was it that made you want to talk about this at this time?
like over the last year, I found myself more and more using functional paradigms in D. And at the same time, I found myself to having to debug less. And overall, I liked the code better. And yeah, that's what prompted it.
And how much functional experience do you have outside of D?
Not much. I tried to use Haskell some time ago, and we have this small internal functional programming language at Symmetry. But other than that, it's not that much. I mean, I've done a little bit of probably Haskell people are going to pull their knives out right now, but I've done a little bit of functional in Python, but or like functional snippets, I would say. But other than that, not that much. I mean, I'm an Emacs user. I'm sorry, I'm a Vim user. If I would have been an Emacs user, I probably would have had some more experience in functional programming. It just sort of came to me after a time that D is really good at functional programming.
But without that experience, I mean, like I didn't have that experience. You say you didn't have much experience. So how did you fall into it? I mean, why are you so enamored with it?
When I sort of started, that like the first thing that gave me not really trouble, but I didn't like was like if statements. And at some point you realize that you like do some initialization in an if statement, and like then like the other branch of the if is not taken, your data is not initialized in like the correct way or the way you want it. And I started finding using ternary expressions. And like over time, I realized that like I wrote like 200 line files without any if statements. And because I was using ranges already, because Phobos is awesome and ranges are all over Phobos, I basically had files without any control statements. Yeah, and then I would say like 90% of the way to being a functional programmer, or you are already a functional programmer if you program something that functions, but using a functional programming language. Yeah, and then it sort of spiraled out of control to a degree, I would say.
Attila says to make code as functional as possible, but not more. Sometimes a loop is the way to go, but I still feel dirty. I'm if you know, I'm a dirty guy, I guess, because I always go for the loop first. I have to force myself to think functionally. I just
No.
I'm not there yet. I don't
Yeah,
use it enough.
yeah, I would agree with Attila, and that's the cool thing about D. I mean, if you have like pure functional D, and at some point you realize there's this one assembly instruction that like shaves off 90% of your runtime cost. Use inline assembly in functional D. I mean, why not? If it works and you can sort of make sure that the stuff you want to achieve with that one inline instruction does what you need to in a correct way, of course. And if you have to have a little bit of object-oriented programming in your functional D, sure, that's the cool thing about D. I mean, it is a functional programming language, but it's also an imperative one, and it's also an object-oriented one, and it's also fully templatized thing that you can like use in any way you want.
So we are on, and you're talking about higher order functions. You are defining C in this talk as a functional language because you can pass function pointers around. I think some people would take issue with that.
That was the intention. I mean, you have to have a little bit of clickbait and controversy to get people excited.
Why would you want to ruffle the feathers of functional purists?
Like as we sort of discussed earlier, the cool thing about D is that it's not pure, like it's not a pure functional programming language. It's not a pure object-oriented programming language. And the way you can program functionally in C gets you pretty much all the benefits you get out of functional programming, at least in my opinion. And just because like old school C programs have all their state in like global variables, that's not the way you have to use it, right? You can use it that way, but you don't have to. And just because like other functional programming languages force you to not have any global state, that's obviously one way to do it. but it's not the only one, I would say.
Well, here's an interesting point raised in the live chat. It's not a question, but how do you defend putting a comma, separating a comma on a new line like that?
Because I also did a little bit of Elm programming. And when you ever have, like, if you write out your structs or your struct literals or arrays over multiple lines, that is very easy and convenient to command out certain elements of that struct literal or the array. So the comma is not so you don't have a dangling comma at the end. It actually looks really, really good after you get used to it.
Funny thing, when you first sent me the video, I almost was going to point that out to you as an error. And then I saw you doing it on multiple slides. I was like, it's intentional. Interesting.
Yeah, and I guess the good thing about 2020 is we will not meet up in any hallway where I can't run away if you don't disagree with my syntax. So
here we go. D has the trailing comma. Right.
Yeah, I replied just, Steve. They are in, but they shouldn't be allowed. It's the syntax with the commas at the beginning is way better.
So where'd you get this diagram from? Is this all you, or did you pick it up somewhere else?
That's all me. I mean, that is my awesome picturing skill in LaTeX with ticks. Took me way too long to get that picture the way it's looking.
Yeah, for those who aren't able to see the diagram we're speaking of in the future, if you're watching this, some distant future post DConf Online, he has a diamond here with D at the top, correctness at the bottom, testing on the left, and what was the right side? What was that?
So there's basically like a fully connected graph between testing, D, functional, and one more thing, correctness.
Correctness, yeah. Okay, we got to read this one out loud. This is on the live stream. Robert, your talk about, what is that, structurizer in DConf 2016 was interesting. Have you continued this project since then?
No, but parts of that have been used in other projects and actually are used currently internally at work. But the basic idea of generating like boilerplate and input for other languages has continued in my work quite heavily. As I would say, any good programmer, I strive to make myself obsolete at some point, and I will spend quite a bit of work to get there. Yeah, generating everything, I would say, is sort of in a deprogrammer's genetics.
This is not a question for you, Robert. I don't think this is a general question. Is there a quick check live for D? And I wonder, Matt, are you talking about a linter? If so, I think we do have one in, I forgot what it's called.
DScanner.
DScanner. There we go. DScanner. Yeah. So I was talking to Ali earlier about how to explain ranges to people, and I noticed you just jump right in to the heavy stuff here. This is not a beginner's tutorial. Anybody who, I'm not knocking it at all. I'm just saying this is an advanced talk on ranges. But I know there are some people who are going to look at this slide that we're looking at right now, file, byline, copied, map, joiner, blah, 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 all the way down to the bottom there, and they're going to be lost. When I look at this, even when I'm looking at my own code that I write, I'm lost. I'm confused what I'm reading. I have to actually stop and work through it step by step by step. How does it work for you when you're looking at it? I mean, do you see the whole thing just at a glance, or do you have to stop and think about it?
I mean, it sort of depends. If I've seen it a couple of times or if I've just wrote it, it's usually there. But the cool thing about writing it this way, like one line by line, is that because of uniform function call syntax, you can actually read it from the top to the bottom. And you just sort of have to carry the return type of the previous line in your head. And that is one of the things I find that makes functional programming in D easy. Like the syntax or the way you actually write it down makes a huge difference to me when I read it. So if that would be one line, or let's say 2 lines, understanding what's going on is, I find, a lot harder than having like one statement at one line. And I think later there's an example where I basically have 2 filter calls just behind each other, and every filter is only filtering out like one condition, or one is looking for one thing. And like very recently I got a comment on like a code review from a colleague who said you could join those 2 filters in one filter, or those 2 expressions into one filter. And I said, yeah, I know, but that is intentionally. This is easier for me. I sort of have the feeling that the use of mobile phones and computers where you can copy paste stuff sort of shrank down my short-term memory to a degree where I can focus on one thing very deeply. But if there are two things, I'm lost.
Well, you touched on something there that's interesting. An aspect of ranges I find interesting as they're implemented in D is that there's often more than one way to achieve the same thing, and it's not necessarily a bad thing. It's not always easy to see which way is the most efficient. And I think it's pretty interesting when somebody will post a question in the forum, how do I do this in range style programming? And somebody will come in with an answer, and then somebody else will come out with another answer, trimming it down or expanding it or whatever. And there's 3 or 4 multiple different answers to do the same thing. It's like all these building blocks. Do you see that as a strength or a weakness?
I see it as a strength. And I also see there's like two things I would say to learning D. Like one is learning the language itself. And the other one I would say is learning phobos. I would even say that learning phobos and probably knowing most functions or most modules by heart is the more important bit about learning D as a whole than knowing all the small intricacies of all the D features. I would say with like map, filter, reduce, and a little bit of knowledge on how to use functions, most programs are like easily written and easily maintained. Knowing whether or not a delegate is stored on the stack or not, or like if it's allocated, you shouldn't care. Use phobos and move on with your life.
Well, the slide just before the one we're looking at now, it said you were giving what your definition of a range is something that for each can something for each can iterate. And when I first saw that in the video, it made me do a double take. I was like, wow, why didn't I think of that before? It seems like a simple way to explain it. I always describe ranges as a view over a container. But that's not always true because sometimes you have like iota, which isn't a view over any container. It's a generator. So ranges can be generators, but something for each can iterate. That seems to be, I wonder, is that the simplest definition we have? Anybody else can come up with a simpler definition, or is this disprovable? Are there other things for each can iterate that aren't ranges?
Like while researching
Static
this,
arrays.
I looked into the D documentation, and the only time the language itself worked in conjunction with ranges, or ranges were relevant, or the concept of a range were relevant in any way, that was for each. And I mean, for each reverse as well, but I mean, that's sort of that anyway.
Objects with op apply are not ranges, and for each can iterate objects with op apply, right? How much of this kind of code are you guys using in your Symmetry work?
A lot. I mean, D is the main language we use to implement SIL, or is the language used to implement SIL. And there are quite a few people now at Symmetry that program D. And I mean, people's tastes are different. And also, like, if the code works, usually we not try to we're not dying in beauty and making it perfect. If it works, why touch it again, right? But for new code, I sort of try to convince people to do it a little bit more functionally, but of course, like people have their own opinions on how to do it correctly. But I mean, the cool thing about a D conference talk is if you get accepted, you get to talk for an hour or so, and nobody can contradict you, at least if it's like in the video where you are talking.
Yeah, they can only contradict you in the YouTube comments later on.
But that's fine. I mean, that's proper scientific discourse, right?
Do you find a lot of use for infinite ranges, or any use for infinite ranges? No.
I mean, as the next slide will probably tell us, I find there are only two ranges or two range types you actually have to care about. It's the input type, and there is the random access. All other, meh.
Are there any range interfaces you would change? Let me put it this way. Are there any range interfaces you would change or eliminate?
I would say no. But then I haven't thought about that like as a means to achieve hard enough. Most of them I find like I have to use most of them sometimes. Like practically I find that if I can't use an input range, I call array on it, making it a random access range.
I was going to say, what about output ranges? Do you use them at all, or do you just stick with the global put functions?
So like the two things I do quite often is basically have an output range, and at some point I often use formatted write, and that takes an output range as first parameter. And then the cool thing is you can get a locking text writer from files to write out text, but also you can pass in an instance of appender to fill out that. And if you write a function that formats text in whatever way, and the outputter or the output range you use or the type of that is defined as a template type, testing, so getting output to std out or putting it into an appender and then writing it to something else is quite convenient.
Well, we have one person in the live stream chat saying that forward ranges are useful. Save is often implicit, and that's considered a problem because algorithms with bugs forgetting save will work 99% of the time. You know, we often sell D to C++ programmers or Java programmers. How would you sell D to a Haskell programmer?
That's a tough one. I would try to say that if people find, or if the Haskell programmer finds Haskell to be too strict sometimes, he should try D. Because you can, as discussed earlier, decide when you want to be strict and when you just want to write a for loop and do it the ugly way, which works and is fastest. And the cool thing is you can sort of jump between the two or jump between any paradigm in D very quickly. That is, I think, the strength of D.
Okay, easier state than Haskell in case state is necessary in a small portion of the logic. I see, that's an option to pedal D to Haskell. It's easier state than Haskell in case state is necessary. Yeah. Okay.
And mostly state is necessary.
Robert, I think you mentioned having used Elm language. How would you compare with D? What do you think about the Elm architecture?
Like the thing I like about Elm is the architecture. So if people don't know, Elm basically is like the Redux pattern of JavaScript or of React is baked into language. There's only one way. Like you have a model and you have a view function, and the view function displays that model in your HTTP page or in your HTML page. And then you have an action, and that basically takes your old model, the action, and combines that into a new version of your model. And there's no way around that. Because it's a functional programming language and it's a very small functional programming language, usually what tends to happen is when your program compiles, there are no more runtime bugs. And that is a very strong statement. So far, I found it to be true. I haven't been able to get any undefined or any runtime bug in any of the Elm programs I've written so far. And to be frank, they're not that big, but it's a really awesome paradigm. The only problem is if you have a program that requires something else than having a model that is displayed and then you apply one change to it, it becomes difficult. And of course, there's no concurrency in it. And interacting with the command line is quite difficult. So for web programming, Elm, absolutely. And as I said earlier, the syntax or the way of writing struct literals and arrays, I stole directly from them. And I have no shame admitting that. I'm not ashamed admitting that.
We just saw the UFCS slide, in the uniform function call syntax slide in your talk, Robert. I think a lot of people who have been using D for a long time, and even people coming to D for the first time, enjoy uniform UFCS, especially with range programming. But I know there was somebody who said in the forums recently that he thought it was a bad idea when he gave an example of or he was talking about an example of using a string literal as the argument to WriteLine with UFCS, like hello.WriteLine. And I'm wondering, in your own use, I mean, do you draw a line on where you use UFCS? Are you willing to use it anywhere on literals and WriteLine calls and whatever else?
I saw the example, and I was thinking that for WriteLine and strings, I would use WriteLine opening parentheses and then the string literal. But usually what I find is that I'm using write-fline pretty much all the time, because just printing hello world, those are no longer the programs I get to write. Yeah, most of the stuff I call functions on, and I call uniform function call syntax on, or functions on, are on more complex shape of objects. And on literals, yeah, writing down literals is usually not something I do. I mean, if I have to do math, usually what happens is that the input to the math expressions or the math calls come from like some data I have to ingest or so, and they end up in variables. So I'm not just writing like 42, then like divide by 2 as a function call. That just doesn't happen.
Well, I remember when UFCS first got introduced as an official feature and not as an accidental feature of arrays, expanding on the accidental feature, I should say. A lot of people thought it was pretty cool to use it on integer literals, especially with like units of measurement
Yeah.
time and that kind of thing, and that's pretty cool. But and actually, I guess we have that in the datetime stuff in Phobos, right? We can use literals, but I don't really see that outside in other code. But I tend to view UFCS as like saying, oh, this is a property. This function is a property of this thing, kind of as an extension. That's why I
Yeah.
would never use it with write line. I don't ever use it with write line. It's not the complexity of the function call that or write f line. It's not the complexity that I think about. It's just what's the concept. And I'm curious what other people say. Give us your thoughts in the live stream chat here about UFCS. Do you have any limits on how you use it? Do you think it's a bad idea? Whatever. What about dropping the parentheses?
Sometimes I like it and sometimes I don't. I can't really say, like, there isn't a like fixed cutoff point somewhere. Yeah, it really depends. What I would say sometimes happens, like for instance, I'm pretty sure joiner doesn't have a second argument other than the range. And I think I've never used parentheses on joiner if I called it via UFCA. But if I use, for instance, a splitter, I think I usually use parentheses, even if I use the default argument, just to remind myself that there could be something else I want to split on. To a degree, I think it's spike chatting. You do it if everything else has been said.
Mathis Beer unqualifiedly loves UFCS and dropping parentheses. And here's an argument from Dennis. The biggest problem with UFCS for me is that DCD doesn't autocomplete it. I hear that a lot when we talk about autocompletion and IDE. And so I'm not a user of autocompletion. I mean, if it's there, I'll use it, but I usually don't think about it. And so, but I know a lot of people do. What's your take on that?
Like in Vim or NeoVim with, what's the plugin? Like there's one plugin that actually works quite well, and that also works on like free functions. So it's fine. And even if it doesn't, like if I sort of know, at some point I usually know all the functions in my program, or at least the most I use. I just type in the first 2 characters and press some magic on my keyboard and Vim does the rest.
We had a question in the talk chat. Are these compiler features? Okay, Robert's talking about coverage, code coverage in his talk right now, coverage analysis, and he's talking about the compiler features that you can use to do that. And the question is, are these compiler features DMD specific or part of the language spec, and therefore implementations are required to have, for example, unit tests? And Robert says, I think LDC can do coverage as well. Walter, you're still here with us. I don't know offhand. Maybe you do, maybe you don't. But if anybody knows offhand,
Yes.
is the code coverage features and stuff like that unit test, are they DMD? Well, I know unit tests are in the spec, but the code coverage features, are they in the spec or are they DMD only?
No,
DMD
that's
specific
that's
compiler.
an implementation thing. It is not part of the language.
Yeah.
It's a quality of implementation thing. They have code coverage built in.
Yeah, and that's another thing. Handling exceptions. You're all in. Some people avoid. Some people
yeah,
avoid in range chains.
Yeah, but I mean, sometimes you can't. And it's good to know that Phobos has something that can handle exceptions and ranges. Even though the handling in this way, like just returning 0 as like the return of that state then, might not be perfect, but it's better than sort of aborting the program just because you get an exception.
What do you say to people who talk about exceptions and performance?
I mean, that's again a tough one. I usually see it, or how to put this, 95% of the code I write is not performance critical. Like for instance, right now I'm mostly working on a system that also has networking. So there's like network traffic. No matter how much work I spend on making the backend faster, the network is still going to be the performance factor. So I would say the same with GC. Don't care. Like if you get to the point where like exceptions and the GC is actually important, you probably have other problems. This GC angst, so the fear of the GC, I think is unwarranted. It's just sort of a killer argument to not have to discuss the merits of D. Yeah, I would say just don't care.
We have a couple of questions now in the live stream chat. Ranges and immutable data types. How do we make people test their ranges with immutable? And one suggestion is that from Auburn Sounds, our friend Guillaume, he says you instantiate them with immutable like a boss.
Yeah, I mean, the cool thing about D then again is you like one of the cool things there is static for each, and just qualify your type and instantiate a sign and let it rip.
And Robert,
Yeah.
would you miss any D language feature for implementation for implementing Elm architecture, perhaps algebraic data types? And you answered this already with a big.
No.
There we go. Yeah. Why not?
Yeah, and because everything is there. I mean, the only thing that you have to then do is like stick to the architecture. And the architecture of Elm sometimes is really annoying because you have to like do always this like great big loop in it. Yeah, I think the biggest problem there is that you have to be strict with yourself not to get out of that architecture to have the benefit of it. Yeah, if you can do that for a long enough time, you will probably have very, very easy programs to understand and probably bug-free as well.
Mathis has rephrased his question about immutable. How do we make people take immutable seriously as a requirement for ranges to test with?
Yeah, I mean, that's the bigger part, right? Writing the software is the easy part, but convincing people that doing something is correct is the hard part. I mean, I'm trying to convince colleagues at work to do certain things all week long and I fail. So I'm probably not the best person to ask.
I was kind of wondering, what about the state model? I'm not a functional programmer by any means. So, I mean, I'm wondering what was your big focus on state here for non-functional programmers? Why were you including this much about state in the slides?
Because quite often, like if you have a long range chain, you're just doing like batch processing, like in the way you would use your bash. But quite often you have programs that have to carry state. And I think that is like an important part of functional programming that like is not talked about that much outside of the functional programming community. I wanted to sort of put a focus on that to make sure that people not can just come up and say, it's functional programming, but I have state. And here you have an example on how to handle your state in your functional program. And also like on the next slide or so, like a couple slides later, I think there's a nice example where one of the D features plays in very nice on how to copy your state and thereby make it very easy to compare like old and new state after a function was applied to your old state. And here again, I think is a great example of writing struct literals this way with the comma in front is great because it's very easy to see where stuff is and like what are the order of elements and so on, just to get people a little bit more annoyed here.
And for people who are watching this stuff, watching this live stream post DConf, we're talking about the section of his presentation that's he's got a find group example where the group is his state, the program state. It's an imaginary program state. That's the section we're talking about here. Since we got Walter here with us, do you have anything you'd like to ask him about the current state of functional programming in D?
Actually, no, and I think that's a good sign. It's very easy to do functional programming in D. It's all there. Like, how to put this?
Robert. Usually when a question like that is asked, I get a long laundry list of...
No, like the only thing I think that D can take, especially again from the Elm community, is the Elm compiler has awesome error messages, very detailed, very sophisticated. They take the context of the place where the error is or is occurring. Like they use that quite a lot. And like the only thing I would say is that like the quality of implementation of error messages can benefit from like looking at what the Elm people are doing. And I know the Elm language is a lot easier, but still the error messages are awesome.
Oh, that's good to know.
Well, how much functional do you use in D, Walter?
Not a whole lot, mainly because when I think of doing something, I always think in terms of loops. And it's a really deeply ingrained pattern in my mind. And it's just, it's hard for me to think in a functional programming way. So that's not a fault of the language. It's just more of my experience, just moving to the core, and I do things the way I've always done them, and it's hard to break out of that. But when I'm able to make something functional, I'm usually pretty happy with it because it very rarely has a bug in it. Functional programming, it's also related to making. Normally, when I'd write code before, I'd combine things like gathering information and then doing something with that information. So in other words, I'm gathering information and I'm mutating state at the same time. Sometimes I've taken code that does that and I've redone it into two functions, one of which gathers information and the other one mutates state. And I've been very happy with the results of that. It's the code's much easier to follow and much easier to extend when I do it that way. And that's sort of splitting your code into functional and non-functional pieces. And yeah, when I've been able to do that, I've been very happy with the results, and that's a very different way than I used to program.
We have this question in the live stream for Robert. Do you think no throw by default will hurt range programming? And he answered it already in the chat. So can you go ahead and tell us about it, Robert?
Saying that no throw should be the default, I think that is forcing you to do something. And I find that D is about having the choice to do something. And I find there's sort of a tension between having like something prescribed by the compiler as a default other than doing the choice by yourself. And I often write like a no throw column at the top of my files. That is my choice and it's not done by the compiler for me. So yeah, I think it will not hurt range programming, but it will maybe hurt your non-range programming. And I also do non-range programming or non-functional programming in these. So like I'm not for forcing people to no throw or pure or no GC. I love the GC. I'm an idiot at memory management.
But yeah, there's another thing too. You used Neu instead of the German Neu. And I when I first saw that, I said, oh my God, it's just an error. And then I was, oh, right. Neu's a keyword. Yeah, that is cool. I never thought about that before. Is that common among German programmers, or is that just what you do?
I don't know. The interesting thing is like most German programmers I know use English in their programs, even for comments. But I was like typing new because I had older new, and of course the compiler said, "Nah, you can't use new there." And then I was like, "Ah, shit, what do I do? Like a 3-letter word for a new thing." And I realized, I know a different language. I'm just going to use that one there. Yeah, so the first if statements right now on slide 42. And that's, I think, one of the cool parts. You can use functional programming for a whole lot, but then sometimes they're creating a copy of an object, like a little bit of template magic and static ifs and static for eaches. And you get your copy of whatever structure you have in very few lines of code.
Maybe my poor memory management is hurting me here, but I don't recall you talking about functional purity in the talk.
I did a little bit at the beginning. I said that D has a pure keyword, and I described it because that's like the one difference that, or the one thing that C doesn't have.
Yeah, but you didn't really go into detail about it, and I wonder, what I want to ask, I guess, is it something you have to think about with functional programming in D?
Usually I find not. Like even sometimes I find like files that are full of functional style functions and they're not marked pure. But then if you look at them, you just see that they get some input and then return some output and never touch any outside state or do anything impure.
Yeah, I know. I mean, it's. I remember there was this big deal back in the day about strongly pure and weakly pure and how we managed to handle that in D. And I think it's been so successful that it's not an issue at all. I mean, it's just, it just works. Ali says about your deep copy implementation. I have the same at work. In my case, I take advantage of static versus dynamic arrays as well. D rocks. Nothing to add?
Yes.
Do you do a lot of deep copying in your code? You guys deal with like huge data sets, right?
Yeah, on the SIL side, yes. I mean, huge. They are big, but huge. I mean, I think we're not talking terabytes yet, but kilobytes definitely. But right now I'm mostly on another project, and there I have like a fully fledged group implementation and like members and subgroups of groups and stuff like that. And there I do deep copying, all of it. I found that to be the right approach, because when I mutate data, like the debugging of it was very difficult. And the cool thing is, if you have like an old state and a new state, and that is deep copied, and you just print them side by side, you can actually, like if you JSON serialize them somewhat, you can use, and if you pretty print them, you can use off-the-shelf diff tools to see the differences. And then it's very easy to find the places where you messed up.
How many deprogrammers do you guys have at Symmetry?
I don't know exactly. I think last week we had a meeting with like 32 people in it. But I think that is not all, because now there are people in so many different time zones that some people were sleeping when the meeting happened.
If you have anything to talk about the conclusion of the talk to add to it right now, please go ahead, Robert.
Yeah, I think the most important part is the first statement, if statements considered harmful. I find that code without if statements is a lot easier to get correct. Ternary statements are the future, if statements is the past. It's like the go-to of the 2020s.
I actually agree with you on that. The more control flow you have, the buggier your program is.
Yeah. And also the cool thing is that sort of the argument of like where to break lines, should it be 80 characters, should it be 100 characters or 120? Like if you have no if statements, that is never a question. Like your line will naturally end at like 60, 65 or so. Probably a minor point, but still.
Okay, what's this about not using if statements? What's the alternative?
Yeah, ternary statements, that's the alternative. Or rewrite your code into a range form that you don't need if statements. And quite often a combination of the two, that is the alternative. Yeah, I mean, what the feeding character is just saying, I have long lines, mostly due to long type names. And I guess that's like the other big problem in computer science, right? Naming things, like cache invalidation and naming things.
I was thinking another thing that's related to no if statements and no control flow is a single assignment of variables.
Yeah.
Which is each of your variables is only assigned once and never again. I've started to adopt that in my own coding style, and I really like the results. It makes the code much easier to read. If I want to reassign a variable, I look to see if I can actually, instead of reassigning it, create a new variable with that new state. And I try to reorganize my code so variables are only assigned once. Sometimes that means breaking out some of the logic into a sub-function, like a nested function or something like that. But it really makes the code nicer and more pleasing to read when you do it that way. In the olden days, I would reuse variables, even though they were for very different purposes, because I thought I was like saving stack space. Well, the reason for that disappeared about 30 years ago, and it took me a while to adjust my coding style. The compiler is actually pretty good about if two variables don't overlap in their uses, they can share the same memory location. So the compiler optimizer will do that for you. There's no reason for you to write code like that. So I've been gradually fixing my code not to do that anymore.
Well,
but yeah, I think that goes hand in hand with that, the single assignment approach. I'm not sure if it has a name. Single assignment works for me.
Okay, Ali has a question here in the talk chat. Okay, we're talking about the concurrent programming in your, or multi-threaded programming in your Encore here, and his question is synchronized synchronized AB is supposed to sort. Is that implemented yet?
I would say no.
Walter, many of the languages we use at work have a single assignment feature. For example, const in JS. However, D's transitive doesn't always allow that. For example, in ranges. How about using final for that?
Oh, I've thought about that many times. I think final on variables would be a good addition to the language. If I recall correctly, there were some syntactical ambiguities with the existing uses of final, which would have to be addressed. But I thought many times that would be a worthwhile improvement to the language. Another thing you could call it as is is head const, which would also alleviate Ali's complaint about the lack of flexibility of const. So head const would be like the way C++ operates, and it would also enforce single assignment rather than it just being some stylistic issue, which is, the way I'm doing it now.
Synchronized AB does what Robert explained, difficult to implement.
It sort of depends. I mean, if you think about like what you have to synchronize in order to do the action or to change state of that thing that is shared, it usually is not. I mean, the synchronization doesn't have to come, or the sorting doesn't have to come because of sort. You can also just hard code that. You just have to make sure that everybody's using the same sort of static coding or the static sorting. But you can also try to contradict one of the other requirements for deadlocks that also works the same way. But I find that sorting or breaking the cycle by sorting is the easiest. So Peter asked, what feature am I missing from DAP? I mean, one, it should be faster, and two, the dependency resolution should be redone. And I tried to start work on that, but then I got sidetracked with other things I had to do. So yeah, one day.
Okay, any other